Alright, in this past question, we'll be seeing 2024 WAEC chemistry theory questions. So the first one here is, what is an electrochemical cell? An electrochemical cell is a cell that generates electricity from chemical reaction. A cell that uses chemical reactions to generate electricity, like the Lagrange cell, or you can say is a device that converts. Can equally say that it is a device that converts chemical energy to electrical energy. So, which means you can use chemical changes and generate electricity. If you watch one of my videos on this channel, you see where I used chemicals, copper plates with copper solution, zinc plate with zinc solution, generate electricity that powered the bulb. You check for it on this channel and watch. So we move on. Maybe I continue using my blue. Okay. State three differences between an electrochemical cell and an electrolytic cell. First of all is that based on maybe we might have a table. Here should be our electrochemical. Remember, in general, electrochemical cell includes any cell that converts chemical energy to electrical and even electrical to chemical. Just like when we say electromagnetism, in general term, electricity and magnetism in just. So electrochemical cell at large view contains galvanic cells, that's chemical cells and electrolytic cells. But in this context, I mean they want us to narrow it down. So what I mean is that electrolytic cell is still a type of electrochemical cell, because both the cells are all making use of converting electricity to chemical to electricity. So that's it. So but let's take it this way: electrolytic cell and electrochemical cell. First of all, this one uses a chemical change to generate electricity. Uses chemical change to generate electricity. While this one uses electricity to bring about chemical change, specifically direct current. Coming to the setting of the cells. In the electrochemical cell, anode is the negative electrode. While cathode is the positive electrode. In electrolytic cell, the opposite is the case. Anode is the positive, while the cathode is negative. Negative electrode. That's it. Okay, they say 3. Also, you can split anode is negative, but in real sense, electrochemical cell can proceed spontaneously. Reactions in electrochemical cell can be spontaneous, meaning electrochemical cell can happen naturally in life, but electrolytic cell, no, you have to set it. You must supply external energy. So we might just simply say spontaneous, supports spontaneous generation. This one doesn't operate in a spontaneous way, rather it is non-spontaneous, meaning like rusting, iron rust. When iron rust, most times maybe iron coated with zinc, when it starts rusting, electrochemical cell is set up there. But In nature, you cannot see electrolytic cell. Okay. So the next one says, explain briefly what would be observed when powdered zinc is added to a solution of copper 2 tetraoxide 6 solution, copper 2 tetraoxide 6 in a beaker. This is about displacement reaction. They say explain. They did not tell us to write explain. Remember, copper 2 tetraoxide 6 is blue. That's displacement reaction. So what will happen is that the blue color of copper 2 tetraoxide 6 disappears, turning colorless. The blue color of copper 2 tetraoxosulfate 6. To save time, let's use the formula live and direct. Disappears and turns colorless as the zinc dissolves to displace reddish brown particles of copper, to displace copper 2 ion from the solution in form of a brownish particles. So these are the things that will happen. We are done with this page, so automatically we'll go to the next page. Okay, guess it should be the continuation. Okay, they say write an equation. They say write an equation for the reaction in 1C. That's copper 2 and zinc. So the equation is zinc is in solid state, of course, reacting with copper 2 tetraoxosulfate 6. I think I prefer using blue. So it's sounding somehow here. Zinc plus CuSO4. This is S. State of matter is necessary here to give us Cu now S plus zinc tetraoxosulfate 6, now aqueous. Alright, balance if it is not balanced, but the equation is naturally balanced. State the type of reaction. States the type of reaction which takes place in 1CII. The type of reaction that takes place is what? Displacement reaction. Now, name 2 gases which should be prepared in fume cupboard. Sulfur 4 oxide is advised because it's also poisonous. Chlorine gas, all these poisonous gases, hydrogen sulfide, any of these you can select. Carbon 4 sulfide is also advised to be prepared in fume cupboard because they are poisonous. Remember, fume cupboard or fume hood, they ensure that gases are taken out of the laboratory so that the suction pressure takes away the gas. So it's an expensive apparatus. Give 3 factors that favor cracking. Factors that favor cracking, like cracking of petrol. Okay, of course, that should be temperature, because we have the thermal cracking which goes with temperature. Then if temperature is there, pressure certainly. And then catalyst, because of catalytic cracking. Yeah, these are the 3 common ones that I know. Give the reason why noble gases are chemically inert. Because they have achieved octet or duplet configuration, because their atoms have octet or duplet configuration. Or one can say because, or because they lack bonding electrons. It's still true. They don't have any electrons for bonding. Okay. State 4 properties of homologous series. 4 properties of homologous series. We don't have space here, so I will answer above. I'm talking about this one. I'll answer normally. Number 1, they have general molecular formula. They share the same general molecular formula. Successive members differ. Successive members differ in their molecular structure or molecular formula by a methylene group, or in their molecular weight. They differ in their molecular weight by 14. They share similar chemical property because of common functional group. They share similar chemical properties because of common functional group. They have share similar chemical properties but different physical properties, actually, at least because of their difference in molecular weight. Different physical properties. Again, they have similar method of preparation. Remember, similar doesn't mean exact. Similar method of preparation. Okay, like if you talk about the alkanes, you want to prepare alkane. So all the members, maybe you want to prepare methane. You just need to heat soda lime with the next member, the sodium ethanoate, ETH. If you want to prepare meth, you heat soda lime with sodium ethanoate. With sodium ethanoate, of course, yeah. So we want ETH, we want meth, we use ETH. So if we need ethane, we will heat soda lime with sodium propanoate. See, now if we need now propane, if you heat butanoate, sodium butanoate with soda lime, it will probably give you propane. So they have this similar method of preparation. Okay, I guess we are done with this. Remember, you can also tell the examiner they have the same functional group and they follow regular structural pattern. There are many other things you can do. So we can now go to the next page.
Hi, I wanted to tell you that you can contact Her Majesty is World for your laboratory equipment and reagents. They are affordable and provide accurate results too. Her Majesty is World only sells what he knows, and his patterns of delivery are sure and certain. Place your orders today. Thanks for your patronage.
Prayer gets number 4. Okay. Over here, this one says continuation. Over here, this one says, what is global warming? Global warming, funny enough, maybe warming of the globe. Okay. Global warming is just a prolonged increase, a prolonged rise in temperature. It has to be sustained, something. Prolonged rise in the average temperature of the Earth. Prolonged rise in the temperature of the Earth's surface due to increase in the concentration of greenhouse gases like CO2. Okay, So average increase in the average temperature of the earth, not just that it increases in a day and stops, but it is sustained. State one cause of global warming. Burning of fossil fuels, of course. Deforestation, yeah, burning of fossil fuel. So you can say deforestation. Why do burning constitute global warming? Burning will yield CO, which when completely oxidized gives us that gas CO2, and CO2 absorbs heat, which leads to increase in temperature of the earth, is a greenhouse gas. Then deforestation is to kill plants that will make the environment clean by removing CO2, because plants uses CO2 as one of the raw material for photosynthesis. So deforestation means just falling trees, cutting down trees and not planting any, either by using bulldozer or even human activity. So as you reduce the number of plants, unfortunately there will be higher CO2, because it's plants that will remove the CO2 we animals breathe out. So deforestation will cause global warming. Okay, we go to the next question. Let's check. Okay, over here I don't think. Say in the extraction of aluminium, name the substance rated at the anode. Advantage of, I don't think this, it didn't act like a saturated solution. Checking. These things are not arranged well. So what am I gonna do now? Okay, I think, yeah, this is weird. That should be number 5 question, Seth. Never mind. I think what I'll be doing is each one I see the question I will answer it. Let me finish up with this one. State the class of oxides to which each of the following compounds belong. I think this is an easy question. So sodium oxide, what class? State the class of oxide to which each of the following compounds belong. Sodium oxide, of course, is a basic oxide. Reason, because it's an oxide of a metal. Metallic oxides are called basic oxide. Then zinc oxide can also be basic acidic, and therefore it should be under the one in between, amphoteric oxide, alongside that of aluminium oxide and lead. Then sulfur oxide is an oxide of non-metal, and that makes it acidic oxide. There is an acid anhydride. Carbon dioxide is also an acidic oxide. It's also an acid anhydride of soda water you drink. Nitrogen 2 oxide is called laughing gas. It is neutral, just like nitrogen. Okay, this is nitrogen 1 oxide, please. Nitrogen 1 is laughing gas. Nitrogen 2 oxide is also neutral. Water is also a neutral oxide. They now say write the chemical formula of alumina. Alumina is the product we get from a purification of bauxite. At the end, you will get purified alumina is simply aluminium oxide. There might be different forms, the delta, the alpha ones, but Al2O3. In the extraction of aluminium, state one compound that is used to obtain aluminium from bauxite. Okay, that should be concentrated sodium hydroxide. As a solvent for alumina during electrolysis, it should be cryolite. Name the electrodes used in the extraction of aluminium. The graphite electrodes, both the anode and cathode are graphite. Give reason why extraction of aluminium is expensive. High cost of electricity, and again the cost of replacing the high cost of, because the anode is burnt down continuously, high cost of replacing the graphite anode. As oxygen is liberated there, it burns it down in form of converting. Remember, graphite is carbon. It's going to convert it to CO2 eventually, and you need to go and replace it with time. So this is amounting to extra cost. Okay, go to the next. Okay, this is, I think this should be the continuation. This should be the continuation. So here it says, name the substance liberated at the anode. Oxygen gas. Write the equation for the reaction that leads to the decrease in size of the anode. That's what I just wrote the other side, but we can repeat it again. Remember that the anode is graphite, and graphite is form of carbon, which means when it's attacked by oxygen, it's burnt down in form of CO2. Don't go and write the equation at the anode here. They say write the equation for the reaction that leads to decrease in the size of the anode. Because what is happening here is that, remember, carbon atoms are neither lost. There is no, at that carbon rod, the carbons are neither losing or gaining electron here. Do you understand me? Rather, it is the oxygen that migrates there that causes the liberation of oxygen gas, and it's the oxygen gas that actually attacks the carbon, reducing it. So the real equation that reduces the anode is combustion, which is still oxidation, or maybe to stay on the surface side, you can still write 2O2 minus. When it loses 4 electrons, it will become oxygen. But this one should be the correct answer. Give 2 ions that cause hardness of water. Okay, that's calcium ion and magnesium ion. These 2 ions are responsible for the hardness of water. They are soluble salts. State 2 advantages and 2 disadvantages of hard water. 2. Advantage is that it leads to development of strong teeth and bone. It does not attack lead pipe. That's one advantage. So this is advantage. 2, it doesn't attack lead pipe, but unfortunately it's outdated because we no longer use lead pipes in power supply. Then what are the disadvantages? I think there are many. Leads to wastage of soap. Number 1, wastage of soap, or making laundering very difficult. Doesn't lather easily with soap. That's difficult to lather with soap. That's what I mean. The number 2 is that it causes fouring of kettles, broilers, and even pots. That's the inside being coated with dull deposits of calcium carbonate, of course, causes fouring of kettles, boilers, and equally pots, the inside of the pots if we use it for boiling. What is meant by destructive distillation of coal is the process of separating the constituent of coal by application of heat, and by so doing the coal is destroyed by subjecting. It involves subjecting coal to heat, separating it involves the separation what I do, it involves just the separation of the constituent of coal actually by heating. So in destructive distillation of coal, coal is heated in the absence of air. Yeah, let's put it that way. It involves the heating, not the heated. It involves the heating of coal in the absence of air, driving away the volatile constituent, the absence of what? Air, to actually break it down into its components. Let's use that word, to break it down into its components. So we have the volatile and the non-volatile components. The non-volatile residue which remains behind is the coke, of course, while the coal gas, they are volatile. Ammoniacal liquor. Name 4 products obtained from the destructive distillation of coal. We have coke, coal gas, ammoniacal liquor, then of course coal tar. Other further question? We will go to the next page. And now it's called destructive distillation because the coal is destroyed during the process. Do you understand? To break the coal down irreversibly. I would like us to put here to irreversibly break down, because that's why it's destroyed. Irreversibly break down into its constituent. Because if you talk about petroleum now, I'm sure if you mix kerosene, petrol, all the constituents that come from crude oil, it will still form back that crude oil. You have not destroyed it here, but in the coal aspect, like wood, you cannot take it back. Okay, we'll go to the next question. This one is question D. Imagine, where did he? That's so funny. This must start with this place. Yes. Honestly, I think, you see, 2D, in order of increasing acidity. So what do I do now? Permit me to answer. Maybe I will answer serially. Anyone that is like this one is good. It's D, but we can start. Yeah. Okay, then this question, this one says a saturated organic compound X containing 3 carbon atoms. We should mark that 3, and it's highlighted. Reacted with butanoic acid. I don't know if it is clear on the screen. Yeah. Butanoic acid in the presence of dilute HSO4 to form a sweet smelling. Hence, we have had sweet smelling compound Y, that's ester. So they are taking us to esterification. Esterification is actually the reaction between alkanol and alkanoic acid to form esters and water, just similar to neutralization but not exactly the same. So they have told us the acid, which is butanoic acid, and they say 3 carbon for the alkanol. That's it. Of course, X is an alkanol specifically containing 3 carbons, and that's C3H7OH. Following the general formula for the primary alkanol, CnH2n plus 1OH, they have told us that N is 3. Automatically, when N is 3, that means the total carbon atoms we have propanol. So because we were told to write the name it, we are going to write propanol. Okay, then for the product, which is Y, we have to write the equation. First, they say butanoic acid. We have to write the equation and name the compound form. Butanoic acid is having 4 carbons in total, so don't be deceived by writing C4H9COOH. No, if you do this one is pentanoic acid. Pent because this 4 plus this 1 carbon here gives us 5. So this is not butanoic, this is pentanoic acid. So what must we do now to write pentanoic acid? Just remove 1 carbon from the pent, 1 carbon from the butanoic acid. For us to write butanoic, remove but is 4, so if you remove 1 from 4, it becomes 3. It becomes C3H7COOH. So that when you now count, you see we have 3 plus 1, that gives you 4. That's butanoic acid. Plus, plus now C3H7OH. We should remind ourselves this is not the answer yet. I'm just writing so that we can find the product. But to remind you again on how to get the products from esterification, we have RCOOH, that's for the acid, plus ROH. If they react in esterification, let me put prime here to make a difference. Which R is written first? The R from the acid is written first, and the R from the alkanol is written last. So looking at this expression here, for the alkanol, here is the alkyl group, alkanol C3H7. For the acid, here is the alkyl group, which is still C3H7. So for us to know the product, we are going to just write out first COO. Now, close each gap with the R. Thank God the 2 R's are the same, so we are lucky. We are going to just have C3H7, C3H7. But remember that the C3H7, this particular one, is the one attached to the acid, which is probably this particular one. So it's written first. Okay, so the product formed is, they told us to get the name, so let us now name the product. In naming of esters, you watch one of my videos here on how to name esters using alkyl-alkanoic system. So we name this one first, 3 carbons, and hence propyl. Then coming here, we have 3 carbon, 3, this 3 plus this one here 4, so it will be propyl butanoate. So we are going to fill in that here X is propanol, while Y is propyl butanoate. Propyl butanoate. Okay, just fill it. Y here, remember this is X, is propyl butanoate. And see, then they say state the functional group of X. This is just bonus. Of course, the functional group is hydroxyl group, or you say OH. Write an equation for the reaction. That's the one I've cleaned. You just repeat it. C3H7OH plus C3H7COOH to give you, from what I told you, we are taking the R from the acid, which means if this one is C2H5, we will write it first, but we are lucky it's the same R. Then COOC3H7 plus water. Remember esterification. So this is the acid, this is the alkanol. Okay, this is now the ester, that's the sweet smelling whatever. Then that's the equation they want us to write. Next question says probably, I don't know, but we are starting a new question. Write a balanced equation for each of the following reactions. Ammonia gas with copper 2 oxide. Ammonia gas is a redox reaction, of course, plus CuO, copper 2 oxide, that's CuO, will give us it will automatically, the ammonia will reduce the copper oxide to copper metal and itself oxidize to water and nitrogen gas. Yeah. Now to balance the equation, we start from nitrogen, which has only 2. So we balance it off here. Hydrogen is 2 here, but it's just 1 here, so we must put 2 here. And the 2 we added here affected hydrogen. It has made hydrogen 6 on the reactant side. We go to product side and make it 6 by adding 3. 2 times 3 is 6. And the 3 we added on water affected oxygen. So we go to the reactant side and balance oxygen, make it 3. So this is where we have the oxygen. So plus, so over here should be 3. And this 3 affected copper. 3 is here. Imagine that. States of matter necessary: solid, liquid, and gas. Okay, ammonia gas with oxygen gas. Oh boy, this is not ammonia react with oxygen. Is it not? Oxidation of ammonia gives us HNO3, but there should be a special condition. Okay, yeah. Ammonia can burn in oxygen with pale green or greenish yellow flame. Yeah, plus oxygen to give us water, of course, and nitrogen gas. Balancing is where there is error. We have 2 already here, but I'm afraid 2 will not balance it. Reason is because hydrogen is already 3 here. So if you put 2 here, if you put for compensation of oxygen, let's try the 2, but 2 will not go. 2 will not work. Well, let me try it. 2 here. Unfortunately, 2 there has made hydrogen become 6. And here is 4. So, does it mean we put 3 here? Maybe, probably. To balance hydrogen. What about oxygen? What will we do to oxygen to make it 3? So, an even number is what must be here. This is another way to learn this balancing. Odd number, we go. Numbers like 4 can stand. When 4 is there, here should be automatically 2. And when 4 is here, to make up with hydrogen, what must you multiply 3 by to get 8? So it's not working. We move to 6. 6, and that makes it 12. Is working with 6. Okay. And when 6 is there, automatically here is going to be 4. Because 4 times 3 is 12 for hydrogen. And when here is 4, here is going to be 2 for nitrogen to balance. And oxygen will now be 3, will be here. Yeah, that balances the equation. State of matter, gas. It's going to all be gases. Yeah, it's homogeneous. Now, aqueous potassium iodide with chlorine gas. This is displacement reaction. Potassium iodide, Ki, plus what here? Chlorine gas. This is because they told you aqueous. This automatically displacement reaction. There will be potassium chloride aqueous plus iodine being displaced, which is going to be solid. Balance the equation. There should be 2 here and 2 here. Okay. Then iron with dilute tetraoxosulfate 6 acid. Always check if it is sulfate 6 or sulfate 4, but this is sulfate 6. Fe plus H2SO4. Since they say dilute, be careful. That means it's displacement reaction. Remember, if they say here is conc, it's going to liberate sulfur oxide, but since it's dilute, it will just liberate hydrogen gas, which makes it easy, though the other one is placing conc. So take notes in next exam. Remember, you're on with Some Majesty Easy Words. Please subscribe and share this video. Expand this science community, please. Please, my dear. You know you're my love. I cannot do without you. Then I appreciate you for the ones you have done so far. God bless you so much. Okay. What do we say? Will give us now FeSO4, of course, plus hydrogen gas. Remember, we were told to balance everything, and we are lucky here. Everything is balanced. This aqueous, this is solid, this is aqueous. Then the next one, V, aqueous lead 2 trioxonitrate 5 with hydrogen chloride gas. This is displacement, double decomposition, sorry. Lead 2 trioxonitrate 5 aqueous plus hydrogen chloride gas. Automatically there will be double decomposition, exchange of radicals, where chloride ion comes to lead, giving us solid, and the hydrogen goes to HNO3, giving us the acid. To balance the equation, we just need 2 here. And when 2 is there, automatically we will also need 2 here. So the state of matter, this is aqueous solid and then aqueous. We go to the next page. Carbon side. Okay, these ones, it might not be serial, but permit me to be answering them the way they are arranged here. Okay, this is a calculation. I guess we have to answer some question before this one. I think this one connects. I've seen question on Charles law. Let me go back. Okay. And this is where it should continue. I don't know why this thing was not numbered. But rather just take it that way, no problem. Okay. A gas occupies 150 cm cube at 21 degrees Celsius. What would be the volume if the temperature is raised to 45 degrees Celsius and the pressure is kept constant? At constant pressure and volume temperature varies, we use Charles' law. So using Charles' law, we have that V1 over T1 equal to V2 over T2. So what are we looking for? Check what they say. What is what? Okay, what volume? Okay, that's V2. Automatically making subject to the formula, cross multiply. V2 is equal to T2 V1 all over T1. We now go put in our values. Our T1, our T2 is 45 degrees plus 273 to convert to Kelvin. 45 plus 273, we can do horizontal addition. 5 and 3 is 8. So we carry nothing again. 4 and 7 is 11, 1. So 318 Kelvin, if I'm correct, of which I know I am. Then T1 is 21 degrees plus 273. Same additional mathematics. We have 1 plus 3, 4, 7 and 2, 9. So we have 294 Kelvin. Then volume remains what it is. Our V1 is automatically 150. So coming to substitute values, our V2 is now T2, which is 318 times 318 times V1 150 all over T1, which is 294. Okay, so I'll be forced to find calculator here. So we are dealing with what? Maybe let's confirm the other mathematics we have done. 45 plus 273 is 318, which is correct. Then 273 plus 21, 294, we are also correct. So we move ahead. 318 times 150. You can predict the answer actually, because the temperature increased almost by more than times 2. So the volume will also increase. We are going to get something around 350 or so. Divide by 294. 160. I'm wrong. Why did I predict wrongly? Is it not directly proportional as the temperature is increasing? Okay, the volume increased, but not as I predicted. Oh, sorry. Yeah. My prediction was in degrees. That's why I failed it. Remember, if you want to follow the prediction, predict in Kelvin. 318 and 294 is not times 2. So 162 is correct. So we have 162.3 cm cube. Is it up to 3.2? Plus 4 is not up to half. That's our final answer. Okay. We scroll. Write chemical equation to illustrate what happens when each of the following oxides is dissolved in water. Sodium oxide, being basic oxide, will give us a base now. Sodium oxide plus H2O. They say chemical equations. Okay. It will just form sodium hydroxide. They did not tell us to balance it anyway. This is chemistry. Any equation written must be balanced. So we just need to put 2 here, and that satisfies everything. Phosphorus 3 oxide plus water. Oh boy. This one is not easy for the children. Phosphorus 3 oxide is a dimer. 3 should be P2O6. If I'm correct, 3 times 2 6 minus 2 times. No. Phosphorus 3 oxide is, how will it combine? This should be 3 instead. Yeah, not 6. But it's a dimer, which means this is normal phosphorus 3. Am I correct? 3 times 2 here is 6 minus 2 times 3 is 6. Okay, but it's a dimer. You multiply all by 2. That means, remember, monomer is the one you know very well. So when I say mono 1, dimer, just 2 units, mono 1 unit. So it's a dimer, meaning it doesn't occur singly, just like we have diatomic gases. Some compounds are dimers. So in writing this, the little I know, even the phosphorus 5 oxide is also a dimer. Should be written as P4O6 plus H2O Definitely, this is the acid anhydride of phosphorus 3 oxide. So we'll be looking at phosphorus 3 oxide, which is H3PO3. Balancing the equation H3PO3. Will any other thing form? Nothing again. No, is supposed to form. Because of the 4 here, we should put, let's check. Putting 4 here has made hydrogen 12. Putting 6 here. So, but 3 times 4 is unfortunately 3 times 4 is unfortunately, okay, it's 12. I'm correct. Why am I trying to confuse myself? I want to make it 24 now and I will walk till I tire. Yeah, this is correct. This is supposed to be, I don't know if solid though. So to avoid, let me leave the state of matter. Okay, then chlorine 7 oxide. Oh boy, asking O-level student, this phosphorus 3 and chlorine 7 is not good though. Why I should take it easy on these children now? Is this one in scheme? I'm sure most have not even seen chlorine 7 oxide. But since they say chlorine 7, remember that oxygen is always -2, of course. So since it's chlorine 7, you check how to combine 7 in even number. It's going to be at least 2. So 7 times 2 is 14. So how many times will you multiply 2 by to get 14? So which means oxygen will be 7. So we have Cl2O7. This is chlorine 7 oxide. Let's check. What I mean is this chlorine is plus 7 already. Plus 7 times 2 is 14. Then this is -2 for oxygen times 7, 14 to give you 0. Plus water, which will give us chlorate 7 acid now, because it should be an acid HClO4. It should be the correct thing. Now the question is on how to balance it. Let's try to here. And that to balance everything. Imagine the miracle. Yeah. But I'm sure this is too big for an O-level student. But if you are majestic, you will tackle it, of course. This oxide, I wouldn't know the state of matter. Honestly. But it's giving us an acid. I'll take it as a gas, and it's an acid anhydride. Okay. Because oxygen now is 7 plus 1, 8. 2 times 4, 8. Okay, magnesium oxide, which is not all that soluble in water, but is a basic oxide, plus water, of course, gives us magnesium hydroxide. Magnesium hydroxide is naturally balanced. Oxygen is 2, hydrogen is 2. Remember, this is 1 plus 1 here too. Okay, we are done with this page. We go to the next one. Okay, this one says the second ionization energy of, we must answer another one before this one. We can't just see second ionization energy like that. I think we have to tackle this one first. The liquescence is just the process whereby some solids absorbs enough moisture to form a solution. Some solids, the process when exposed to moist air to moist environment or moist air to form a solution. And they will dissolve in it. Remember, the liquescence and hygroscopy, they all absorb water, but hygroscopy will just become ordinary sticky or moist and not enough to form solution. Efflorescence is also the process whereby some compounds, some hydrates loses phenomenon. You can say this is the phenomenon. Hydrates or solids loses all or some of its water of crystallization when exposed to air or atmosphere. Okay, this one loses, so it is not a drying agent, rather is a wetting agent, but students often mistake it because they say it loses. When they say drying agent, it means something that brings about drying, not that is the thing drying something. So it can be a wetting agent, but hygroscopy and the liquescence can act as drying because they absorb. So if they come close to what is wet, they will take the water. Give one example of a substance that undergoes each of the process in 2A. This was even question 2. Okay, the liquescence. For the liquescence, the liquescence includes sodium hydroxide, potassium hydroxide, calcium chloride, zinc chloride, zinc nitrates, iron 2 and iron 3 chlorides. Okay, there are many. Pick from the variety of options. Then for efflorescent, washing soda, efflorescence, the one that is beat that, washing soda, which is sodium trioxocarbonate 4 decahydrate, also sodium thiosulfate, pentahydrate, sodium thiosulfate, 6 pentahydrate is also an efflorescent. That's Na2S2O3.5H2O. What is meant by ionization energy? This one depends on the concept. They did not tell us first ionization or second. Ionization energy is just the energy required to remove an electron from an atom to form a positively charged ion. Simple. This is the energy required to remove electron or electrons, depending on remove electron or electrons from an atom or from a charged particle or from a molecule to form positively charged ion. Form positively charged ions or ion only. So that's it. But when they say first ionization energy, you can now say the energy required to remove the most loosely bound electron from a neutral atom to form a unit positively charged, but they just said ionization energy. We have first, second, third ionization energy. Okay, in a more funny way, you can even say the energy required to form ions, ionization, but you need to be more specific, like this one here. Okay, we said we'll go back here after. The second ionization energy value of sodium is greater than the first ionization energy. Briefly give the explanation for this observation. Second ionization energy of sodium is even impossible. The energy is too high that to achieve it is not easy. But calcium, you can achieve first, second. Aluminium, first, second, third. Reason is because I want us to get something clear here. If we work by KLMN, sodium is number 11, which is 281. If you want to write the normal distribution in the subshells, 1s2 for sodium, 2s2, 2p6, and 3s1. Okay. As far as chemistry is concerned, the electrons in the outermost shell is what can be removed. So ionization energy is for removing the electrons in the last shell. Electrons in the inner shell are untouchable during bonding. So these 2 and 8 cannot be removed. Why? They are in a more stable shells because K and L are all stable. To remove or add to them will be difficult. Remember, we answered question why noble gas do not react. But when there are 2, let's assume for magnesium now, like 2 here, you can have first and second, whereby you can remove the first out of these 2 and remove the second one. But for sodium, it becomes impossible here. But that we will not write for them that is impossible. What we will answer here, you can give 2 good reasons. But for you to get the good reasons is this. If you use this one now, you remove the 3s, which is of higher energy level, and the energy required to remove from the last shell. Remember, P is of higher energy than S. Remember, S, P, D, F. S is lower, followed by P. F is the highest. So if you remove the first one, remove this electron here, that gives you first ionization. The next one you are removing from P, which is more stable and of higher energy. So you need to apply more force. Do you get now? So it's just because you tell the examiner the second ionization energy in sodium involves removing from the 2p subshell or removing from the stable L shell. Is stable because it is completely filled. It involves removing from the completely filled L shell, which is very difficult and requires high strength, and that's why it's impossible, like I told you. So another reason is because there will be increase in nuclear charge. See what we mean by first and second ionization energy. If you have sodium, when sodium loses 1 electron, it will increase by Na+. This is first ionization energy. I wouldn't write the other one because the second is not possible. But do you believe that when sodium loses 1 electron, it is now left with 11 protons and 10 electrons? And these electrons are outside the nucleus, while protons are inside. So there will be excess positive charge in the nucleus. Thereby, the nucleus will have more effect. That's what we call nuclear pull on the rest of the electron remaining because positive charge is now in excess. To remove from a positively charged particle is difficult than removing from a neutral. So if you want to remove, that's why first ionization energy is very far more below second ionization energy. It's not even times 2. Second ionization energy is usually almost times 3 of the first ionization energy. Reason is because second ionization energy involves removing from the inner L stable shell. It requires extra energy. But this question is not for children. Briefly give explanation for this. Because in sodium, the second ionization energy involves removing, because in sodium, the second ionization energy involves removing from the inner stable L shell. Which requires extremely high energy, almost impossible. because it has attained duplex stability due to octet, please. Due to octet stability caused by losing of the first ionization energy. And again, it is secondly, there will be increase in nuclear charge. Secondly, due to increase in nuclear charge. Why I said increase is that protons are not actually added, but protons were made to be excess. So therefore, increase in nuclear charge will cause that to have effect on it, okay? Then state Charles' law. Charles' law states that the volume of a given mass of a gas is directly proportional to its Kelvin temperature, to its temperature in Kelvin, or if you like, to its, this its shouldn't have this apostrophe, to its temperature in Kelvin at constant, you must put it, pressure. In other words, volume varies as T, so V is left with KT. Sketch a graph to illustrate Charles' law. A graph to illustrate Charles' law. A graph to illustrate Charles' law will be plotting in many ways and it will still be correct. Remember that we are going to be dealing with temperature against volume, or volume against temperature, but the units, if this temperature is in Kelvin, it will give us a positive line graph that will pass through the origin. Volume, the unit doesn't affect it. It can be in anything, but for the sake of the mark, you must say maybe cm cube. Then another way is the same way we have okay, if we have the same volume being plotted against temperature, but this time around, if the temperature is in degrees Celsius, it will be a positive graph, but it will not pass through the origin. That's a fact. So this is temperature, but in degrees. Take note. If it is in degrees Celsius, and here is volume, it will be a positive line graph, but hanging, whereby if you trace it to the temperature axis, you get minus 273, while here is 0 degrees, minus 273 degrees Celsius. So any of this is accepted, or if you plot the one I can remember, I think if you plot V over T and T in Kelvin, it will give you a straight line graph. All these are graphical representations for Charles' law. Okay, and to make everything, to secure every mark, just say pressure is constant in each case. That's it for this page.
Subscriber. Bye. Thank me later.